instructional video is on graphing lines in slope-intercept form. In an equation in slope-intercept form, it references the equation y equals mx plus b. The m is referenced for the slope or the rate of change. B is the y-intercept or initial value. So in the equation, y equals 3x plus 1. The 3x is the slope, and the 1 is the y-intercept. Now, when it comes time to graph the equation, we graph the positive 1 first, and we graph it on the y-axis. It's a y-intercept. It goes on the y-axis. And then we use our slope, focusing on our fraction rise over run. So for the number 3, we would rise 3. There's no number for a run on the denominator, so we just put 1. And so we would go up 3 and over 1 to make our line. You can also go down 3 and over 1 to continue that pattern. And you should end up with a straight line all the way across the graph. 2, again, we are referencing our slope-intercept form equation, y equals mx plus b. M is representative of our slope, and b represents the y-intercept. So in the equation, y equals 1/2 x minus 3. 1/2 is our slope, and negative 3 is our y-intercept. We graph the y-intercept first, which is our starting point, negative 3 on the y-axis. Our slope, 1/2, references our rise over run equation. We rise 1 and we go sideways 2. Again, you can make your triangle rise 1 and sideways 2, connecting your dots to make your straight line. You can extend the graph the other direction by going down 1 and over 2, again connecting the dots until they go all the way across the graph. 3, we are referencing the slope-intercept form equation, y equals mx plus b, where m is our slope number and b is our y-intercept. Our slope is the negative 1/3 x, and our y-intercept is the positive 2. We graph the y-intercept first for our starting point, 2 on the y-axis. Our slope is a negative 1/3, which references our rise over run fraction. Because the graph is negative, we're going to go down. So we would go down 1 and then over 3 to make our new point. Down 1 because it is negative, and over 3, connecting our dots as they go until it touches the edge of the graph. We can continue that pattern the other direction, 1 and 3, 1 and 3, until the line reaches both edges. And then we are finished. Last problem, we reference the slope-intercept form equation, y equals mx plus b. M is our slope, and b is our y-intercept. We would fill in our slope value with the positive 3/4 x and our y-intercept with the negative 2. We start by graphing the y-intercept as our starting point at negative 2 on the y-axis. We then use the 3/4 fraction to represent the rise over run. It is positive, so we go up 3 and over 4, and making our new point. We can also go the other direction, 3 and over 4, connecting those points as well until the line reaches all the way across the graph.